Hello and welcome to another video. Today we have an Asus Prime B550 Plus on our bench, and this came to me with physical damage. As you can see, there's a capacitor in this foil that they sent me in this little bag, and that capacitor comes from near the PCIe slot right there, and there's also more damage done to the PCB right there. And as you can see, someone has tried to do some soldering as well, as you can see by this here. So yeah, we will have to take a look at this previous repair attempt, how we can fix this. So because I do not know anything about the board but that, we are going to start with our usual checks of checking the 24-pin adapter. So to get a ground, I made this little adapter that plugs into USB and then has a clip on the end. And all I do is I take my ground probe and connect it to there, and then we have a good ground. And then we start to look at the 24-pin. Let's start with 3.3 volts at the bottom left. Kilo ohms. Okay. 5 VSP. Kilo ohms. Then 12 volts. And 5 volts. All looking fine. The 5 volts is a little bit static, but that's okay. So now we're going to move on to the 24-pin. So from 12 volts to ground. If you have this tab, the closer one is always 12 volts. And we have high resistance. Then we take our probe. We're going to go into the upper point and we can probe the V core and see that there's no MOSFETs shorted from 12 volts to the V core phase. As you can see, kilo ohms is rising. Okay, no initial short circuits, which is very good. But I think we are not going to put power into this instantly, because we want to see for the general area that was damaged there. Let's quickly also check the BIOS battery for some voltage. BIOS battery has 2.9, a little bit low, but still fine. Okay, let's go under the microscope and check the general area. So, this is the area where the capacitor is ripped off, and the remains still are in there. So what is this? 6.3 volts, 560 microfarads. This might be the same one, might be a different one that goes into there. All of the PCIe slots got a little bit of damage, but I don't think that this is going to be like problematic. This one still looks fine, but obviously the clip at the end is missing, which happens so often. Oh, what is... Holy moly. Okay, I didn't expect this. This has even liquid damage. And this part is basically completely gone. This is a double N-channel MOSFET, where the middle two are both gates, and then you have source and drain. We will have to work on this definitely. I didn't expect there to be more than the physical damage that we saw that is going to be near the SIO, but liquid damage as well. Okay, this is just dusty. So this doesn't have liquid damage, this is just, as you can see, just has a lot of dust, but that's about it. That's not too bad. Like the other one that we saw, that was really green, and the legs of that were pretty much gone. But here it's just a little bit of fluff. Okay, so that is fine. Let's continue to look for now here, close to the CPU socket, above the CPU socket. Everything looking fine so far. Let's go to the top right of the board. A lot of this fluff, but no more corrosion damage, which is good to see. So, close to the DDR, nothing special here. Then this is the area for the PCH, then some more memory voltage, and yeah, and here was where we started for where the liquid damage occurred. Okay, let's check to the right here. Looking fine so far, everything. Then close to the power button. Is this cracked? No, it's not cracked. Everything looking fine so far. So another controller of some sort. And obviously another clip missing. But at least no more liquid damage, just that one spot. We are at the bottom of the board. The Aura chip for the LED firmware. In your regulators, maybe MOSFET. Oh, and there's more damage here. So this is the audio controller. And there's a small capacitor ripped off here. That might be necessary, might not be. Yeah, and the biggest damage that we've seen is going to be occurring here around the SIO. And the biggest thing is that this oscillator is missing completely. Like, there's supposed to be a 4-pin oscillator here. And you can see how it's ripped out of there. This trace, okay, this trace is fine. Then let's see, any of these resistors broken. So these got scratched here, but I don't think that any of these are broken. And let's see, yeah, definitely components here. So I don't think that there was anything here at any point. I think this was free. Then with the traces, not too sure. Traces might also be fine. I would say there was a component here maybe, and definitely here that got knocked off. So the biggest one is definitely the clock. Just like the capacitor doesn't really matter, but the corrosion damage that we saw, we definitely also have to take care of. Okay, I don't think we're going to put power into this yet. Let's start with small things. Let's put this capacitor onto here. So for this capacitor, what you can do, this capacitor is basically completely ripped off. It's only hanging on by a thread there. We're going to save this capacitor because, for example, you sometimes have it that you don't know what kind of value has to be there. In this case, I think I will be able to find a board view, but let's just say we wouldn't know. What we can do then, we can save this capacitor. So let's desolder one of its sides. So that is desoldered. So now we're going to clean up these solder pads, because you can see on these solder pads there's the remains of the contacts of the capacitor. So let's take these off. I'm just going to pour a good amount of solder onto them, get them real hot, and then clean them up. And I got the capacitor onto the soldering iron. Let me get this out of here. Sit there. So now the pads are clean. What we can do is we're going to flip the capacitor on its top, where there's still, you can see these two still have solder points, and we're going to use this. And this is the side that has gotten ripped off before. So now we can see we have both sides connected, and to make it clean, we can also use hot air in order to solder it in properly. If you would want to be very sure, like it's already connected and it's already would be working like this, but we can be very sure by using hot air. And there you can see it's now connected properly. And let's quickly clean up the area here. So now the capacitor is nicely in place, and that part is done. And if we have a look at it from the close-up, you can see that it's properly soldered. Like these and this is the point where they have been cracked off. And just to be sure, we're going to check that this isn't short-circuited because of that. And it's not. So next area then is to move. Let's not do the SIO first. Let's first get rid of this, because this I can do without checking a schematic. because I know what this component is. So let's together clean this up here and let's assess the situation. Really not looking great here. So I got to be honest, the contacts are in better shape than I thought they would be. I thought they'd be completely eaten away, like by the amount of green that is here. But obviously we cannot leave it like that, because they will crack and they will deteriorate, or they are deteriorated already. But for example, this contact here, this is totally fine. This is like a little bit, like not damp, but like, yeah. But still, this is going to be fine. And the rest around here also looks still fine. I'm a little bit worried about this one, but yeah, I think this is also fine. So let's take this off. I will be using a knife tip for that, because it's very close to the PCIe. I don't want to be using hot air. So we're going to remove this with just a bigger soldering tip. So let's see how well this still will take solder in order to remove it. So a little bit here, a little bit there. Let's see. Oh, it stinks. But it's taking solder, which is good. But it took a long time for one side to even take some solder. So let's see. Let's do the other side. So now we have solder on both sides. Now what we're going to do is we're going to heat up both sides and remove it just like that. And now clean up again. So area is clean. Let's inspect these solder points now. Okay, so they definitely suffered a bit, but we can check them. So what we can see, this solder pad right here, for example, this one is supposed to be going this way up to here, and then to there and to there. And all of that is given. So that is good. This one is obvious also to here. This is good. Then this one to there. This is good. Then from this one to like there or here, all there. From this to there. And from this one here, also there. That is good. Okay, so we can just solder a new component onto here and be done with that. So let me see to find that component. That is a dual N-channel MOSFET. That is basically on every single board. Like, that is not hard to find. That component is like sand in the ocean, would you call it? Let me get one. So I screwed up a little bit on the orientation. So at the end, I am going to use a little bit of hot air in order to position this well. There we are. Now it's sitting fine onto there. Now I'm happy with that. Component is replaced, and you cannot see that there was liquid damage there before. Looking nice and beautiful. So next area that we have to work on is close to the SIO. We have taken care of 2 areas. Let's now move to the third. So we're not going to be putting on the capacitor yet, because this capacitor is not mandatory. This is just optional. As long as these don't short, we are fine. Let's then see. This is definitely what we will need. And this is the oscillator. Let's see for the traces also here that have gotten nicked. I think they are all fine. So you can see, for example, these ones, they are not cut through. Just the masking got damaged here. It will be easier if we clean up a little bit to see the actual damage. So let's have a good look. So there's nothing broken here. All of the traces are fine. It's just the component missing. Then this one, and these are also fine. This component, obviously. Then all of this trace everywhere here. It's a little bit corroded, but it's all continuous. Then this component, obviously. And what I'm more suspicious about is this trace right here. Interesting what has happened here also. So we need to check from there to like there. Let's get a grinding pen, because this might be the only trace that is actually damaged to a point where it needs repair. So we're exposing good copper, where we can actually check it properly, in order to get establish a well connection, and then check continuity. So let's check in continuity mode. So we're going to go from there to there, and it has continuity. So that trace, even this is all fine. Okay, then there's also these traces, but all of these I don't think are broken. This is just the solder mask that has gotten like damaged, but they're not cut through. As you can see, when we scrape a little bit away here, you can see that there's all of the copper left. Like, these always look like they're completely damaged, but they're not. It's just, yeah, this copper has just oxidized a bit already. As you can see, if we scrape it a little bit, it looks already a lot better. So yeah, as far as it seems, no actual trace repair needed here. All the traces seem to be fine. Just some components that we need to put onto here. Okay, one final cleanup, and then we're going to assess which components we need. I think it's 3 different components here, maybe 4. So we need this oscillator right here. Then we need to check for this component, probably a capacitor, because this is grounded. This is probably a supply voltage. This might be a resistor, might be a capacitor, not too sure yet. Don't think that there was anything there. And not too sure if there was anything here. Like if there was like a resistor bridge or something. Because you can see there's like all of these are connected together, all 4. And then they split into individual signals. This one going there, this there, this there, and this going up. So there might be a resistor array here, like 1K or something. But it might also be that this was never populated. So we are searching for Prime B550 Plus board view. Let me see if I can find that. So I was able to find a board view. So let's check then. So this diode array, resistor array, is this populated? Because there's an XY at the front. Was this ever populated? Where do these signals go? This signal goes to here. Oh, these are LEDs. Okay, let me see if there's an... No, if there's an XY, that doesn't mean that it wasn't assembled. Oh, when it's not assembled, it actually says no assembled right there. Okay. So this resistor array was actually there. So 300 ohms. I don't think that I will be able to find a resistor array with 300 ohms. But what we can do is just put 4 individual resistors for here, and then be done with that. So we're going to see if we can connect 4 300 ohm resistors into there. And then let's see, this was missing. This is 0 ohm resistor. Okay, so this is also very important. This is for 3 VSB going into the SIO. So this will definitely hinder the SIO from starting, because this is just the standby voltage going into the supply voltage for the SIO. So we need a bridge right here. Then what else did we see? I think it was this one, but this one is also not assembled. So we don't need anything here. So 0 ohm, 300 ohm resistors there, nothing here. Then we need this crystal. This is the this is just a 32.768 kilohertz crystal. These are on many boards, so that shouldn't be a problem. And we need a 270 microfarad 16 volt capacitor here. Okay, so the most important that we're going to use first. So these 300 ohm ones are also not important. These are just signals for standby LEDs, I'm pretty sure, but we're still going to populate them. And the important ones for it to actually work is this 0 ohm and then also this crystal. So let me see if I can find this crystal anywhere on one of my donor boards. So right here I found on a donor board the exact component that we need, a 32.768 kilohertz crystal. So on these crystals, actually the only points that are connected are these front two, and the other legs are just they are not even connected to ground. They are just there to hold the component in. So this is also an Asus board. This is a Z270 gaming, no, tough Z270 Mark 1, where we're taking this off from. There's the crystal out. And while we're here, the PCIe clips were missing from the other board. And these still has all of these clips. And these are really easy to remove. So what we need is a flathead screwdriver, a small one. Like for example this one. And all you do is you get into there, into this tab, and you pry this out. And as you can see, they're out. And these are not even damaged. And we need 2 of them. So let's do this one quicker this time. Like that. And we have 2 donor ones, just like the crystal. So, and here we can see, all we need to do to get this attached is, these has these rides that go into there. And then you're just going to push them down into there. And that's it. And all of a sudden you have these clips again. Just like here. So both connected. Let's now go to the crystal again. So let's clean up the area first. So if you want to install this cleanly without using any hot air, we're first going to clean these pads up. And then we're going to use solder braid. And now dropping our crystal in. And let's connect its 4 legs now. And like this, the crystal is in again. Let's now check for this here. So this was actually never fitted, like we saw. Interesting. And here we need the 300 ohm resistors. So let's put the 0 ohm back into here. And instead of actually putting a 0 ohm here, we're just going to be trying to do a solder bridge. So let's clean these contacts off. And what I like to do is just use a bit of solder as a bridge. You can see we now have a 0 ohm bridge there, just with some solder. And now let's clean this here up. So 4 times 300 ohms. Let's see if we can fit these all into here for them all to connect to their proper place. So this one connected here. And let's connect this one also to there. This one there. And this one here. And now let's get some more flux into there and let's hot them into place. Hot air them into place. So here we are. Let's now check their resistances. But as you can see, they are all in place. They look fine, but still. So from here to there should be 300 ohms. There we are. From here to here, 300. From there to here, 300. And from here to there, 300. Yep, that is all fine. And this obviously just being a solder bridge, this is going to be 0 ohms. From here to there, 0 ohms. And the crystal also being in place. Let's clean up that crystal. I forgot to do that. And now our area is rebuilt. Big question will be if like small components like these have to be worked on as well. But I think we got most of it. So the area is looking good again. Still weird to me that there was nothing populated there. But yeah, the board view didn't show anything. And I think all of these resistors here are fine. They definitely got a hit. But it is only a scratch that they have gotten. Like, I don't think that any of these are actually broken through or anything. Especially after cleaning them up, they don't look as bad anymore. So yeah. Let's then put power into this and try this out. So, let's see. We have everything connected that we need now. Maybe a post screen, but we don't know if we get that far yet. But we might be so bold here in order to try that as well. So, then let's see. Passive power consumption. 170 milliamps. That is fine, I think. So, let's press the power button. That looks very good. 2.5 amps. Are we changing? We are changing. I have postcodes running on my postcode tester. And we see LEDs also here. And that looks like boot. Do we get a post screen? Let's see. No signal so far. 2.5 amps. We can see the spikes. Let's see. We are on boot. So the board should be on. It might be flashing like... Oh, there it is. It was just restarting again. Very, very nice. And there's the board working now. Let's get into the BIOS. And let's see. Pressing F1. And there it is. Very great. We can see the Asus BIOS. Okay, let me do some tests. Let's plug a GPU into here and let's populate all of the RAM slots. So now with 4 DIMMs of RAM in here and a GPU, let's see if it still boots up fine. So DRAM LED, probably RAM training. Let's see, 2.8 amps. Yep, stuck on RAM LED because probably these sockets are dirty. I don't think that this will be moving further. We can see 2.9 amps and just a little bit jumping up and down, but nothing really happening, and the stuck LED. So yeah, let me reseat some of these RAM sockets. Yep, and now we're moving further after cleaning out the slots a little bit. So I actually wanted to end the video already, but I remembered I have never had a look at the backside of the board. And I quickly took a look, and good that I did, because there's another capacitor broken off here. No idea what it's for, but it's definitely broken. And we're going to do the same procedure as we did before with putting it on to its top side and instead of its bottom. So I already wanted to end the video, but then I thought to myself, let's have a look at the backside, and good that I did. There was one capacitor knocked off of the V-core face, and also I replaced that electrolytic capacitor that was here near the PCIe slot that was ripped off, the one from here, and I even put a one in from a tough board. So this even got an upgrade for its capacitors, which doesn't really matter. I'm just joking. So yeah, board is now fixed. I'm going to be testing the USB and the NVMe and all of that stuff, but all 4 DIMMs of RAM are working. The CPU is working fine in here. The GPU is being recognized, giving out a picture. I have already tested some of the USB, and yeah, I think this board will be fine. And yet again, physical damage like it happens so often. In this case, it was very obvious, and some liquid damage. Very weird that they come in a combination with each other. Usually there's one of them and not both of them, but yeah, in this case it happened that there was both. And just on that one teeny tiny spot on that dual N-channel MOSFET for whatever reason. But yeah, we were able to find that and also clean that up and resolder good parts. So yeah, I hope you learned something in this video. All of my tools, as always, are linked in the video description. If you want to get one of these current meters for yourselves, I do sell them, and they come with this software as well. So yeah, email me, it is linked in the video description. And yeah, this was Mainboard Medic. Thank you very much, and goodbye.